One. Hi, everyone. Welcome back to another Planetarium live stream. Here we are again, another night of our virtual dark sky caravan, celebrating our dark skies here in northern Minnesota. With me tonight are one familiar face who we've seen in lots of our streams, and another hopefully familiar face, and if not, will be after tonight. My name is Jessica. I'm the director of the Planetarium. I will let Eli, one of our students, introduce himself real quick.
I'm Eli. I'm a physics undergraduate student at UMD.
And our special guest tonight is Astro Bob, Bob King, who is going to be telling us all about the bright planets that we can see up in the sky. Just before I turn it over to him, if you do have any questions throughout, leave them down in the comments. Eli and I will be watching those. And with that, I'm just going to turn it on over to Bob.
Thank you very much. And hi, I'm Bob King, and I'm an amateur astronomer here in Duluth, where I can see pretty dark skies most of the time, thankfully, because I put myself on the edge of town, so I can just get out of town in a hurry. But I'm going to be talking mostly about Mars this evening, which is kind of a newcomer of a bright planet to the evening sky. But I also do want to mention, before we dip into Mars and head off to the red planet, I want to mention that Jupiter and Saturn are paired up right now in the southern sky. As soon as it gets dark, all you have to do is turn to face the south. You're going to see this really bright star there. That's Jupiter. And put your fist out. One fist, even less than a fist to the left, is another fairly bright star. That's the planet Saturn. So be sure to check those guys out. If you have any difficulty finding them, you're going to get a big help from tomorrow night's moon, because the moon, which will be a waxing gibbous phase between half and full, will be passing directly under the planet Jupiter. And we call that a conjunction. So we're going to have a beautiful conjunction of Jupiter and the moon tomorrow evening. Don't miss it. If you've got clear skies, partly cloudy skies, just go out there for a minute and take a peek. I know you'll enjoy it. If you're going to stay up later, though, you're going to be able to see the planet Mars. So we actually have 3 bright planets in the evening sky right now: Jupiter, Saturn, and Mars. And I'm going to take you to a little bit of a slideshow here so we can see more pictures of Mars. And by the way, if my voice gets a little stretchy once in a while we're doing the presentation, it's just because my internet connection is a little on the slow side. So I'll snap back to you in just a moment, so stay with me. I go out with my daughter, Catherine, every single night. We walk her dog, Sunny, Sunny, named after the sun. And we always walk due east during part of our little travels. And when we do, we always see a very bright orange-red star, brilliant light at the end of the road, just coming above the trees like you see in this photograph here. Maybe you've seen this too. This is, and you may have guessed it, is the planet Mars. And Mars is really getting bright right now. As a matter of fact, Mars is currently brighter than the brightest star in the entire sky, which you might remember is Sirius. Sirius, the dog star, which is a winter star, but Mars is even brighter than Sirius, and it's getting brighter and brighter as it goes. It comes up around 10:30, 11 o'clock now in the evening, very low in the east, and then it rises higher overnight. So if you stay up late, you'll see this really bright orange star in the southeastern sky, and that's the planet Mars. Here's a view of the sky with the constellations drawn in for you, including the planet Mars down here on the bottom. The most prominent group of stars near Mars is called the Great Square of Pegasus. And they call it the Great Square because it's, yeah, pretty dumb, I know. It's a square. It's shaped like a baseball diamond, and it's the brightest part of the flying horse, and that's Pegasus. So if you see Mars, you can just look above the planet, a couple of fists, raise your fist to the sky, 1, 2, maybe 3, and there you'll see this great square. So the planet can kind of guide you and help you to find the brightest part of the constellation of Pegasus, the Great Square. Mars itself is located in a much fainter, really long constellation representing two fish. Okay, here's one fish on this end, here's another fish on that end. They're tied with a stringer. That constellation is called Pisces, the fish. And Mars is located way down here at the bottom end, right there where the stringer joins the two fish. Guess what? I mentioned the conjunction Friday night, the one that's coming up tomorrow evening. Well, the moon, as you know, keeps moving across the sky because it's orbiting the Earth, and it moves about one fist to the left or to the east each night. On September 5th, which is a little more than a week from now, the moon, which will be past full in what's called the waning gibbous phase, will be directly below the planet Mars that evening. That's Saturday evening, September the 5th. The two of them are going to be even closer than Jupiter and the moon will be tomorrow night. So be sure to check those guys out. Mark that down somewhere. Put it on your phone to be sure to look up on September the 5th for Mars and the moon. If you have a telescope, and by gosh, I do have more telescopes than I need. I've got so many, I wish I could share them all with you right now, but because of the COVID situation, we can't do that just yet. But I can share photographs that others have taken of the red planet, like this one. This was just photographed on August 27th, and it shows Mars through a telescope. Look at that big rusty orange world. And that's the reason why it is orange. That's iron oxide in the Martian soil. That was formerly iron and came into contact with water at some time in Mars's past. It became rusty material, and now it's blown around the planet by winds and dust storms, distributed everywhere. So we see this rusty red planet in our evening sky. Through a telescope, you can see large dark markings on the planet. Some of these are extinct ancient volcanoes. The easiest, really coolest feature to see on Mars right now is the South Polar Cap. Look at that thing up there. It looks so much like the Earth, which is one of the reasons that Mars is such a fascinating planet to us. It has clouds, hazes, winds, dust storms. It has polar caps, ice, and deep down under the South Polar Cap, there's actually a lake. So there are similarities to the Earth, more so than any other planet we know of in the solar system. Let's take a close-up look at that South Polar Cap. This was taken by a European spacecraft. Isn't that incredible? Man, that is just spectacular. Look at the spiral shape of the ice. That's caused by winds that whirl and whistle around the polar cap area and vaporize some of that ice and leave those beautiful swirls. Matter of fact, it's making me hungry to look at. It reminds me of one of those Cinnabons. Delicious, right? Except I would not bite into this cap because what you're looking at is dry ice. If you've ever picked up some at a gas station to keep something cold, dry ice is frozen carbon dioxide. It's really cold on Mars. The average temperature is well below zero. The caps are topped by dry ice, and beneath them is where the water ice is located. So during the Martian spring and summer, Mars warms up and the caps shrink. So right now, the South Polar Cap on Mars is shrinking, and you can watch that happen through your telescope over the coming months. Let's take a look and compare these two planets. Our planet, the one we just are so happy we happen to be on, right? It's the best place to be in the solar system and maybe anywhere in the universe for all we know. The average temperature on Mars, 60 degrees below zero, compared with about 58 degrees for the Earth, above zero. Much more clement here, at least so far. 60 below. A CO2 atmosphere which has less than 1% the pressure that of the Earth. So on Mars, you can't breathe CO2, obviously. Plus, you need a special pressurized spacesuit if you wanted to walk around on the planet. Although it's a small planet, it is home to the tallest mountain in the solar system and also the biggest canyon. And we'll see that in just a moment. It just far dwarfs and exceeds the size of the Grand Canyon. And most interestingly, Mars does have signs of liquid water. Very minor signs right now, but many, many signs of a time several billion years ago when the planet was much wetter and more Earth-like. This is a nice animation taken by one of the rovers on Mars, and you can see the desert-like landscape, temperature here below zero, carbon dioxide atmosphere, super thin. If you spilled water on Mars right there, it would just instantly vaporize, bubble up, and go into. There's no pressure. There's so little pressure to keep it as water. Liquid water cannot exist right now on the surface of Mars because there's so little atmosphere, unlike the Earth. You see these dust devils forming during the Martian afternoons, and they do swirl up some of the dust in the landscape, and sometimes those dust devils can develop into actual dust storms on the planet. Here's a picture taken from orbit of a beautiful dust storm, and you can see it working its way across the surface. Sometimes these dust storms can swing into a positive feedback loop. The extra dust brought to the surface and floated into the atmosphere gets heated by the sun. That increases the temperature, which increases the wind speed, which makes the storm grow. And some of these dust storms grow until they enshroud the entire planet, as they did just 2 years ago. So a lot of times, if you're an amateur astronomer and you can't wait to look at Mars through your telescope, and it gets close to the Earth, and then a giant dust storm happens, and then it's just an orange ball, and that's all you get to see. After a couple of months, the dust does settle down finally, and you get to look through the atmosphere at the Martian surface. By the way, Mars is the only planet in the solar system besides the Earth. Well, we're on the Earth, but the only planet you can look at and actually see surface features. You can look through to the ground. Mercury, yes, you can, but it's too far away. Every other planet covered in clouds. Every other planet, we're too far away. So Mars is really unique that way. You could see the surface, you could see weather happening on it. Every 2 years, and this is the reason Mars is very bright right now, because you're saying, well, I see it's bright now, Bob, but what was it doing last year? Is this a special time? And I'm here to tell you that, yes, this is a very special time for Mars, because every 2 years, Mars and the Earth get very close together, and that close-up point is called opposition. Here's the Earth, a little blue orbit there going around. There's Mars. When Earth is on one side of the sun and Mars is on the opposite side, the two planets are as far apart as they can get, right? And so Mars is teeny, teeny, tiny. Remember, it's only like half the size of the Earth anyway. And when it's far from us, it hardly looks like anything in the telescope. But the Earth, which is faster, catches up with the slower Mars. And when it laps the planet, which happens about once every 2 years, when it laps Mars, then we're at our closest. And that close point is called opposition. Opposition occurs in October. So we are approaching opposition right now. We're not there yet, but we're on our way to opposition. And I want to show you a really fun thing that happens every Martian opposition right about this time. This starts in September for us during this opposition. And that is Mars appears to move backwards in the sky. It's just nuts looking. And you can see this for yourself. Normally planets, just like the moon, travel across our sky moving from west to east as they orbit the sun. So over the years, they just keep cycling to the east. But around opposition, when the Earth laps an outer planet like Mars, see what happens there. Let's look at the diagram down here. There it's Mars and Earth getting closer. Earth passes Mars. As it does, Mars appears to swing down here, go backwards, and then resume its normal motion. Imagine if the planet actually could do that. That would destroy the whole order of the solar system, wouldn't it? But it's just an illusion. Mars only appears to move backward in retrograde motion, retro meaning backward. And you could actually see this with your eyes if you start looking at Mars now, and then look at it in the coming weeks, and you will see it slowly move to the right towards the west in the direction of the setting sun compared to its current movement of to the east. This is what it looks like in the sky, retrograde motion from the opposition of 2003. There's Mars, normal motion. The Earth, we'll start again. There's normal motion. The Earth laps the planet. Mars looks like it goes backwards, comes back around and does normal. So that's something you can watch for and see with your eyes. Mars and Earth will be closest on October 13th. That's the opposition date. And that date, that particular one, our two planets will be closer than they will be again until the year 2035. So this is really the season. The summer and through the fall and the early winter, this is really the time to get out and enjoy that planet. Maybe take some pictures of it with your cell phone during twilight, or connect with an astronomy club, or bring out that old telescope and point it at the red planet and see what you can see. Maybe you see some Martians, I don't know. As Earth approaches Mars, of course, we get closer and Mars grows larger in the sky. So you can see more details more easily. And it also gets brighter because we're closer. So Mars will get brighter yet in the coming months. And then it shrinks back down as we lap the planet and continue on our way. Look at how big, look at this. My gosh. Jupiter, Saturn, they are enormous, aren't they? Especially compared to the inner planets, Earth, Venus, Mercury, and Mars. Look at how tiny Mars is. You wouldn't think it would have anything special about it, right? Like all the glory would go to the giant planets. But as I hinted at earlier, Mars has some exceptional things happening on its surface that really make it kind of a powerhouse, a kind of a big time planet in a certain way, even though it's small physically. For instance, it has the largest volcano in the entire solar system. It's called Mount Olympus. How appropriate, right? Where the Zeus lived in the ancient Greek myths. Olympus Mons is how it's called these days, and it is an extinct volcano. Here you can see the caldera, where the lava once flowed out of that volcano down the slopes to build it ever higher and ever larger over many millennia. This volcano, when it was active for a very, very long time, and it grew to a very, very large size. We will use the state of Arizona to show you how big Olympus Mons is. 374 miles wide, 16 miles high, far higher than Mount Everest. Just plop it right there to fill up the whole state of Arizona. I wouldn't recommend it, but does help to visualize how enormous a mountain this volcano truly is. Mars also has the grandest of the Grand Canyons in the solar system. You can see it down here when the crust split on the planet because of volcanism deep within Mars, expanded the crust, and it split down the middle, and it ripped this huge gash into Mars called Valles Marineris, which means the Valley of the Mariners. Look at how big this canyon is. 2,500 miles long. Let's see, we go to Arizona down here, and the Grand Canyon would be a little piece about that big, wouldn't it? And here's the Martian Canyon. Can you imagine one day, it might be 50 or maybe 100 years from now, that astronauts would go to Mars, and we will be scaling the cliffs here and exploring these canyons one day, climbing up the slopes of Mount Olympus. This is left for future generations. And you can't really talk about Mars, can you, without mentioning the face of Mars? Maybe some of you are familiar with the face of Mars. It looks like a face, doesn't it? During the early days of the Viking spacecraft, the first orbiters and flybys and the first lander on Mars, they took pictures of the surface. We got our first clear look at Martian features, hills and craters and volcanoes and the rest of it, including this very enigmatic, what appears to be a face. And some people even claim that it was a face. It didn't just look like it, that it was built by an ancient race of Martians and left there as a monument, sort of like a pyramid in a sense. And it does look eerily human-like, doesn't it? Well, we're going to zoom in for a closer look. There was so much curiosity about this feature that NASA made special effort to get some extreme close-ups of it with more recent spacecraft to try to show what it actually is. It may look like a face, but that's only because it's a low-resolution picture. It doesn't show things in fine detail. This is the same feature on Mars, the face. You can kind of make it out a little bit, but what we're seeing here is really a mesa. It's like an old eroded hill on the planet. And no, it is not a face on Mars. However, I have just come across even more detailed images of this, and now I'm a little skeptical because it does appear to show the face of Elvis. It's very clearly outlined here. You can see his eyes, once again proving that Elvis has left the building, but at least we know he's somewhere off on the red planet. What about other things on Mars? You know, it's a funny thing that we have as humans, as people, that we see patterns in things. These seeing patterns in things can help us a great deal find our way through life. Probably very useful skill to hunter-gatherers of long ago to recognize signs and patterns, so that you knew where the animal was headed, you knew what plants to look for, and so on. Well, a lot of times we go a little overboard on that. The face on Mars is one example, but a more recent one is the picture of Bigfoot. Do you see Bigfoot right here? Very prominent. Obviously, that's Bigfoot, right? Except that when you take and measure the features in this photograph, this is about 3 inches tall. This is the original photo. So it's a very tiny, little mini Bigfoot, right? And he obviously looks like a creature, but it's just a stone formation on the planet, 3 inches tall, that has been eroded by the winds over time and shaped by winds and erosion so that it resembles a human figure. But of course, it is not a real person. This tendency of ours to see patterns, and sometimes patterns where they don't even exist, is called pareidolia. So I've got it up there. You'll never remember how to spell it, but it's called pareidolia. Fascinating, isn't it? But sometimes we're our own worst enemy, and we have to be careful to avoid bias and pareidolia when we're examining images. It's easy to jump to conclusions sometimes, isn't it? Well, look at this. This is a fine welcoming party, isn't it? We have the Curiosity rover. It's currently the only rover that is working on Mars. There are several previous generations of rovers that did splendidly on the planet, roving across the surface, sampling rocks, taking incredible landscapes. This is the most recent one that, again, is still thriving on the planet. It's launched, it arrived in August of 2012. And there you see it off to the right. It's called Curiosity, a perfect name. And Curiosity landed right down here in this little oval. See that? That red oval there? That's its landing site in this big crater about 96 miles wide, pardon me, called Gale Crater. And in the middle of Gale Crater is a high point called Mount Sharp. Take a look at Mount Sharp now. Look at that vista. Isn't that amazing? I mean, this thing looks like somebody went down to Arizona again, right? Or out to New Mexico, set up a few cameras and got a beautiful picture of sedimentary rock, that layered rock. And these layers, as you know, in layered rock, they're like pages of a book, and they tell a story of deposition, how water and wind eroded the rocks on Mars and deposited them as layers of silt or layers of dust, or some of those layers are volcanic dust from extinct volcanoes, perhaps Olympus Mons on the planet. So we have these various layers. And the rover is there now looking, studying this area, and has been for these many years, looking for signs of whether this was a wet environment, whether it was conducive for life to have formed there. And the results are in, people, and it is 100% yes. It has discovered many signs of waters, clays, lake bottoms. Here, let's take a look. Sedimentary rocks. Look at this. This is part of a delta on the planet where water flowed out towards the center of the crater. This is a low area here. And this used to be the bottom of an ancient lake or river system that's now dried up completely and cracked into these blocks. But water flowed down through this delta to fill up that depression that you see in the distance. Yeah, we were there. We are taking samples of that right now. Sure and clear, definite signs that there was water on Mars once, and lots of it. Here's another thing that Curiosity discovered. Look at these pebbles. You might just look at it and go, yeah, whatever. But these are not sharp-edged rocks. These are pebbles. These guys rolled around in a stream. That thing was plowing through the crater, zigzagging whichever this way, that way, and it dragged along that rock. And just like streams, for instance, in the Duluth area, those rocks were rolled and tumbled until they lost their edges and became rounded. One of the best signs of water we've ever discovered on Mars. And then there are pictures taken from orbit of dried riverbeds that once held water, filtering it across the landscape of Mars. Could there have been life there? Yes, possibly. In the very next Mars mission, we're going to find that out. Then there are the teardrop-shaped islands, massive water flows on Mars, not just little rivers like you saw, but sometimes huge areas would just be flooded out, and they created islands that show the direction of the water flow. What could be more obvious? What a different place Mars must have been long ago. In fact, here is kind of a split screen where you can see Mars today, this dry, dusty, very cold world, very thin atmosphere, contrasting with, based on what we know of the rocks on Mars, Mars of 3 to 4 billion years ago, just when things were starting to kickstart here on the Earth with life, Mars was wet too. It had a much wetter climate. What the heck happened on this planet? Well, what scientists and astronomers believe would happen is that because Mars is so much smaller, its core cooled down much faster than the Earth's core. It cooled down early in the history of the red planet. And the core of the Earth and of Mars were composed of iron and nickel, those metals, and currents in the Earth's core moving through that hot liquid that's several thousand miles right below your feet, churning away at this very moment. Currents in that, plus the spinning of our planet, help create a bubble of magnetism around us called a magnetic field. And that magnetic field protects us from dangerous radiation and particle bombardment from the sun. Well, it's hypothesized that Mars lost its magnetic field early because the core cooled. Without a field, the sun's energy stripped away the atmosphere of Mars, atom by atom, molecule by molecule, broke these things apart and depleted the atmosphere to the point where it got cold and where it no longer was possible for water to exist and survive as a liquid on the red planet. So this is the Mars we have today.
Hey, Bob, not to interrupt, but we got a comment from my high school astronomy teacher.
Yeah.
How's it going, Mr. Straka? He asked, did you get your name sent on the microchip for the recent Mars landers?
Yes, I did. I'm there, baby. And I hope you're. I hope he is too. Your former teacher. And by the way, anytime NASA does, is that true? Did you find out?
What was that?
So I'm sorry. Go ahead.
Oh, I was just gonna say, I'm sure. I'm almost certain he is, and yeah.
It's really fun. Anytime NASA sends a spacecraft to Mars, you can get your name sent along with it, and you could print out a certificate with that too, so you could show it to all your friends and saying, "I'm going to Mars. I'm off this planet right now." But we can visualize in this kind of a painting, I guess you would call it, what Gale Crater actually may have looked like a couple of billion years ago. It was a lake, an enormous lake, and Mount Sharp in the middle of it was a higher point within that lake. It was just sediments that settled out from wind and water. And the water drained away, and now we have this barren place, but the signs are all there that it was filled up once upon a time. Well, we're going to Mars again. And Eli, I don't know, or if your teacher sent along your names with the Perseverance rover, the Mars 2020 mission. This was launched on July 30th. I love it. When you launch a craft to Mars, you do not have to wait 6 months, I'm sorry, not 6 months, but a year or 5 years to get there. It's relatively close. So we will be on Mars again. The Perseverance rover will land on the red planet on February 18th of next year. So just a matter of months from now. And its goal is a wonderful one. It kind of works off of where Curiosity is right now and takes it to the next level. It's going to be actually seeking signs of ancient life in the soils and rocks of Mars. It will collect samples with its drill. Curiosity also examines samples with its drill, but this will collect them with a drill. We'll collect 30 pencil-like tubes filled with rocks and dust and soil, and it will put them in a cache so that they can be retrieved on a future mission. Isn't that a great idea? How it'll happen is that a mission a couple of years down the road will land at that same area, retrieve the samples, and then there will be a rocket on that little rover, and the samples go into the rocket. It will be launched into orbit. It'll rendezvous with another spacecraft in orbit. The samples will go into that spacecraft. That spacecraft will then launch from Mars and shoot towards the Earth and then return those samples to our planet. So we'll actually have stuff that was right there on Mars back here on the Earth, and they will be looking for signs of life, potential microbes within that material. And the reason they picked a special place to do this is called Gizero Crater, right there. This is just a small piece. Look at this blow up picture, and the Perseverance will land here right near this delta. Once again, a delta, right, where water flowed out once upon a time, maximizing the potential that has water been there long enough that life may have had an opportunity to begin in that place on Mars. That would be so great. Man, we may find out in the next few years whether there are microbes on Mars. So take good care of your health so you can be around to get that news. Some of the other really cool things that are going along with this spacecraft, this is actually, I love the search for life. I think it's just a fascinating thing. I think we can really all connect with that. But we've seen a lot of pictures of Mars over the decades, lots and lots and lots, but we've never really heard the red planet. That's another sensory connection that we will be making with Mars with the Perseverance rover, because it's got two mics on it. One to record as the rover lands, and then a mic that will run all the time and record ambient sound. So we're finally going to be able to listen to what Mars sounds like, right? We're going to hear the winds on Mars. Who knows what else we might hear? Maybe the dust striking the microphone, and pair that up with the images, almost like being there. That's my hope. And then we're also sending a small helicopter. Why not? It's the era of drones, right? So they've got this very powerful helicopter. Remember, we've got a thin atmosphere there, so we've got it's not exactly a drone type propeller. It's more helicopter-like, which will loft it from the surface so it can do some long distance reconnaissance, take video and images. Man, it's going to be so wonderful to experience this planet in these extra dimensions now. Because Mars is relatively far from the Earth, and it takes time for a signal to get from here to the drone and back again, we really can't run it in real time. So here's the pilot right down here. The Perseverance rover will be sending the commands to the rover and telling it where to go, when to land, and so forth. So it'll be done right there in situ using the computer and the Perseverance rover. And sometimes I get asked this, well, how long would it take? When are we going to send people to Mars? Well, I don't know. It might be, 5-10 years down the road, we'll have people there. Maybe Elon Musk will be the first one to get a ship out there, maybe NASA. But a human mission to Mars requires about 1 year and 4 months. So it takes 7 months to get to Mars. That's like kind of a long stay on the International Space Station. Then you stay there for a couple of months, right? And then you blast off and you return home. So more than 1 year, you'd be gone if you were going to Mars. And hopefully we will be going to Mars very soon. I want to leave you with one final photo, and then if you have any questions, feel free to ask. We started talking about how you can look up in the night sky and see that bright star there, that bright reddish orange star, that's the planet. And you can see Jupiter and you can see Saturn, and they all look like bright points of light. Well, you know, the Earth is a member of this family too, isn't it? And from the surface of Mars, you would look out, and you can see in this photo taken by one of the rovers, you would see the Earth just the way you see Mars or Venus or Jupiter or any planet from here. And in this photo, we have both the Earth and Venus visible. We see the Earth as a tiny planet, the way it really is, because every day it fills our life and our vision. But seen from Mars, it's another little bright star in the nighttime sky. And with that, I'll come back to you here and say hello again. My gosh, I feel like I've been to Mars. It's been a long journey. It's been like, what, 60 some million miles. I'm finally getting my head back here in the bedroom. So it's good to be here. I hope you enjoyed learning about the red planet, its ancient history when things were much more pleasant, and its current state where it's very cold there and dry, but yet tantalizing possibility for life. If you do have any questions, I'm here for a few minutes. You can ask anything you'd like about astronomy.
Well, we have no questions right now, but my astronomy teacher from high school did comment a couple other things that I didn't mention at the time. At first, he said he loves our backgrounds, and I know he's a big Star Wars fan as well, so he might be partial to my warp speed. And then also, I thought this was funny. I chuckled when you were talking about the Bigfoot on Mars. He said everyone knows Bigfoot would never leave Remer or Remer. I'm not exactly sure how to pronounce it.
Right, yeah, and there'd be no need to get to Mars. A stowaway, perhaps, in the future, one of the offspring.
Yeah, that'd be a hard stowaway to not notice on your spaceship.
I would love it. I hope somebody someday, a lot of astronauts have a good sense of humor, and we hope someday that someone brings a cutout of a Bigfoot and sets it up outside the spacecraft on the red planet and just has it there as a backdrop. So, well, it's been really fun talking with you all about the red planet and Mars. Yes, Jessica.
Oh, I was just going to say, it is always a pleasure to have you. Whether you're on the Planetarium or here on our virtual shows, we love having you.
Thank you very much. I always have a great time here. I appreciate you having me too.
And if you've enjoyed it, leave us a note in the comments if you want Bob to come back. Maybe if we get enough of you asking, we can convince him to come back again.
I just might be on an interplanetary journey. Don't take any offense if I don't come back for a few weeks. I will return.
All right. Well, again, if you do have any questions, now's a great time to ask. I have a question for Bob. Because we've been talking the past few nights about like telescopes and what you can see up in the night sky, what do you think would be the kind of smallest scope you might need to be able to see those polar caps on Mars?
Well, right now there's just one cap on the planet that's visible. There are always two, of course, but the north one is tipped away out of our line of sight, so only the south one is tipped towards us. You would need at least a 4-inch, nothing large, but you need, I would say, a 4 to 6 inch telescope, which is kind of on the smaller side for a telescope. So nothing really big. And then the main thing is to see that cap clearly is you need to magnify it. So you need an eyepiece in there that'll magnify it 100 times, which isn't a huge amount of magnification. So moderate magnification and a 4 to 6 inch telescope will show you the cap now. And if you see it now and you look a month from now, you won't see it. You'll actually see that the dry ice is gone. It'll have shrunk down to be so small. But good question, Jessica.
Yeah, and that actually, I'm glad to hear it because that does fit in with the recommendations we gave a few nights ago when we did our beginner's guide to telescopes. We recommended anything from a 4 to an 8, not going much smaller than 4, not going much larger than 8 for your very first telescope. So if you're interested in hearing about that, you can always go watch the show that we did. Was that Tuesday? Yeah, it was Tuesday. And get some of our recommendations.
Yeah, that's great that you gave recommendations too. So, because people are always wondering, and I get the question often too, what size telescope, what kind of telescope? And that same telescope will also show lots of good stuff on Jupiter, obviously, right? That you talked about the bands and the moons. Yeah. And of course, you'll see Saturn's rings too. You could see Saturn's rings with a 4-inch telescope at the smaller end of that. And it's out right there to view. So, and the bugs are going away because it's the end of August. So this is really a great time to bring out a telescope and take a look at Saturn's rings and a few other things.
And if you're still waiting to get yours, we did have a telescope live stream on Monday night where I pointed our telescope at the moon and Jupiter. We got some great views. I couldn't quite get Saturn to focus. The atmosphere was really turbulent.
Yeah.
and all the smoke from California. But we will hopefully have some more streams this week as well. I'm not sure that tonight's going to work, but it's looking like we might have some clear skies Friday and Saturday. So we will be back out streaming again. But again, Bob, thank you so much. It doesn't look like we have any questions, just everyone saying thank you for
Great.
being here.
Thanks for
Um,
listening. Great to be here for me.
Yeah, and we have 2 nights left of our virtual Dark Sky Caravan. Join us tomorrow night as Lindsay is going to tell you how you can delve into the world of astrophotography. It's a lot easier than you might think. And then on Saturday, I'm going to be taking you through some other things that we can see in the night sky, other than the planets and stars, some things like nebulae and galaxies, and kind of give you some of these future objects that you might want to try and find at some point. So with that, thank you again, Bob. Thanks, Eli, for your help. And thank you, everyone, for tuning in. And we hope to see you again and have a wonderful night. So bye,
Thanks,
everyone.
Jessica. Thanks.